And hello, welcome to this video. So in this video and subsequent videos, we want to discuss the idea of dependency injection. Because when you look into .NET Core, ASP.NET Core, you will often come into the bump into this term called dependency injection. And as again a first timer, the term itself may seem very intimidating. You don't know what it is about, so we want to spend some time discussing it. Here are some useful links. This Stack Overflow, what is dependency injection? Okay. And then this is dependency injection demystified. You can see this article is really old, 2006. So these are some of the ways, some of the articles I've used to understand dependency injection. Here's one that says how to retrieve a service in Razor pages with dependency injection. So again, all this may be kind of confusing, and that's the whole point of this video. Okay, you want to demystify it, especially if you come from not really a coder at heart, and not doing this professionally. Then dependency injection we'll try to cover and cover dependency injection in a way that hopefully we can all understand. So as I learn, I make videos. That's the way I style this channel. So I've just learned about dependency injection, very important for website building, or rather very important for object-oriented programming in general. Okay, so here's an example of dependency injection, like behind the scenes. I actually did this power converter called BTU per hour to watts. Okay, BTU is called British Thermal Units per hour. British Thermal Units. Okay, so this is an energy unit. Energy per unit time is a power. Okay, watts is 1 joule per second. So I assume you know your physics. If not, maybe we can do dependency injection with a simpler example. Let's say speed conversion from meters per second to kilometers an hour to miles per hour. Okay, so so that's what we can try and do. Okay, so kilometers per hour to miles per hour and other units of speed. So this is something a little more down to earth. All right, so this as you can see, if I do 293 BTU per hour to watts, it is this much, 85 point something, and I put 293 here. It says 293 BTU per hour is equals to blah 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 watts. Yeah, not the best, but it works. Okay, you can take a look at the decimal places. There will be some discrepancy because I use a pretty I use a simpler way of trying to convert these units. I don't put so many decimal places there. Okay, so let's get started. What's this whole dependency injection about? All right, so let's bring up GIMP again, our trusty GIMP. So let's do this, right? So let me start by giving you some context before we come in. All right, so let's say we have a class, all right, and let's say the objective of this class is to convert speed units from meters per second. I want to convert to kilometers per hour. This is a very common speed unit when you drive on roads in Southeast Asia. Then of course you have miles per hour. mph. Okay, this is a very simple example of speed conversion. You want to convert miles per hour to kilometers per hour or meters per second. This is of course the SI unit. SI unit for speed. Okay, of course there are other units for speed as well, like how many times the speed of light. Okay, or how many football fields per second or something. This is or even volume can be measured in how many Olympic-sized swimming pools. We have what do you call that? A lot of units for speed. So like feet per second, ft per second. Oh, this is very ugly. Feet per second. So you imagine having a converter for speed, you probably want to convert two things, right? When you convert miles to meters, okay, you need probably a class that deals with length conversion. Okay, a class that deals with length conversion, and then you look at the time units here, second. Of course, maybe you want a class that deals with time. Okay, a class that deals with length conversion and a class that deals with time conversion. Okay, so these two will help you convert the individual components. Then you combine them together, you can convert speed. Of course, you can just look at Google and you can tell me 1 kilometer per hour or 1 mile per hour is approximately 1.6 kilometers an hour. So 1 mph to kph. Okay, so it's about 1.6. Yeah, 1.6 kilometers an hour. Right, you can just use that number, sure, fine, that works. But when you do more complicated things with programming, you may not have that option. So I'd rather use this very simple example to illustrate the concept. Alright, so let's say you want to develop a speed converter, right? Speed converter. Okay, a speed converter. Alright, speed converter. Okay, so this whole class here contains a lot of functions or methods. We'll call them methods we'll call them methods as well. It has a lot of methods to help you convert from one unit of speed to another unit of speed. So what will this be dependent upon? Maybe you want to have it dependent upon a length converter, a class called length converter, and a class called maybe the time converter. Alright, so the time converter will be responsible for converting how many minutes is how many seconds, how many months is how many years, or something like that, right? So this is what a time converter does. The length converter is responsible for converting how many inches to feet, how many feet is 1 meter, how many meters is 1 mile, how many meters is 1 kilometer. Alright, so you can imagine these two classes, one is called a length converter, one is called a time converter. They will ultimately be used in the speed converter. So the speed converter is dependent upon the length converter and the time converter. Alright, so remember, so these three, what you see here, these are classes. Of course, they're all related. And of course, let's say you are coding happily. You're trying to code this speed converter, you're trying to code this length converter, you're trying to code this time converter. Alright, the speed, length, and time converter. So let's say you make this class. Alright, you make this class. Okay, and then along the way you find that there are a lot of bugs. Okay, so you find that this whole code here is not working. It's not working because this is a result of bugs. Okay, bugs are, for example, you miss a semicolon here or miss a semicolon there, then the code doesn't work, or you forgot to declare a variable type or something like that. Something goes wrong with your code. Okay, the question is, where in this whole mess of classes is your bug? Okay, how do you do debugging? Right, so could the bug be in the speed code? Could it be in the time code? Or could it be in the length code? Sometimes the what do you call that? The compiler will tell you, okay, this line of code with this line of thing has this error. Okay, sometimes the bug is that simple to fix. Sometimes it is not that simple to fix. Okay, so especially when you have a lot of these dependencies. Okay, so when I talk about dependencies, so this is the main class you want to use. This is the main class you want to use, and then this class here depends on these two other classes. The speed conversion class depends on these two other classes, and these are called dependencies. Okay, dependencies. All right, because the speed converter class has to depend upon a length and time converter. Okay, something like that. So this is what dependencies are. So something could be wrong with the dependency, something could be wrong with the speed. So what is the right way to debug? Well, So you kind of want to, okay, instead of trying to scratch your head thinking about which of these three classes is the problem, you probably want to isolate them one at a time. You want to isolate them one at a time, and then let me test whether this length converter is working correctly. So I'll test, and then I'll say, okay, maybe the bug's not here. Okay, so what's next? I'll look at the time converter, and I'll test. Okay, I'll test, and I'll find, oh, maybe the bug is here. Maybe the bug is here, and I try to fix the bug. Okay, then I will change the time converter, and let me test the speed converter again. Oh, another bug. Oh, where's this bug coming from? Is it the length, the speed, or the time? So I repeat the process again and again. So maybe I isolate. If I figure out that, hey, the length converter is working correctly, and then I check it, okay, so the bug cannot be here. If the bug cannot be here, then it must be either in the speed or the time converter. So let me check out the time converter. Oh, we just debug the time converter. So probably there'll probably be one more bug here in the speed converter. So let me take this class out and test. All right, test. Oh, I found a bug here. Okay, then I solved the bug. Okay, I solved the bug, and finally my speed converter is working. Okay, so this is the general way you want to talk about debugging code, and this is known as unit testing. Okay, unit testing. Okay, unit testing is the idea of, if you have a complex code with so many classes in there, you probably want to isolate one class at a time to see what's wrong, right? So you want to take the length part out, you go and pull it one side, you test the functions inside them, or you test the methods inside them, you see whether they're working correctly. Then okay, let me put it back. Then let me test the code again. Oh, okay. Yeah, so the whole idea of unit testing is that instead of testing the whole code of these things in a very messy way, disorganized way, the way to do it is to take one class out at a time and test them. So, okay, this is how you are supposed to what do you call that? Debug things, right? So this is the proper way of testing your dependencies and doing this thing called unit testing. Alright, so this is a simple example, but let's say let's say you have a more complicated code, and this is your class here, which is way more complicated than, let's say, the speed conversion. Okay, your class is here, and it is dependent upon class 1 and maybe this thing called class 2. Okay, class 2, very ugly, written in a very ugly manner. Okay, so this is your main class which you want it to work, correct? And then you have a class 1 and class 2. But this class 1 and class 2 are kind of complicated as well. Okay, class 1 and class 2 are kind of complicated as well. Maybe you have like you have 500 dependencies on this one. So that means this class here somehow is so complicated because it is dependent on 500 plus dependencies. This class here is in turn dependent on maybe 1000 plus dependencies. Alright, so how then do you so-called isolate? How then do you do this unit testing? Alright, how then do you do unit testing in this case here? Okay, so to do unit testing in this case, what you probably want to do is, if these 500 classes are not your responsibility, they are sort of working, okay, maybe you want to cut this part out, right? You want to cut this part, isolate these 1000 classes and these 500 classes out. Okay, assuming these are all working correctly, okay, we want to cut this part off and then throw it out of the picture temporarily. Then I can test class 1 on its own. Okay, I can test class 1 on its own, I can test class 2 on its own, and I can test this class on its own. Okay, so and I guess in a modern software company, you won't be testing your classes, you won't be debugging alone, you might do it in a team. So maybe person A will do this, person A will do this, person B will do this, okay, person B will do this, and person C will do this. Okay, for those who, yeah, so this is sort of how things might work in a software company. May not always be the case. Maybe someone who's more experienced can tell me, but yeah, you have classes like this, and maybe each of these people, they are responsible for debugging one part of the code. So how do you manage this dynamic going on? Because person C will try to test this class, person B will try to test this class, and person A will try to test this class here, all simultaneously. So there must be a way so-called to isolate all these classes out. So for person C and person B, I think their job is pretty straightforward. But person A may have a little bit of a tougher job, because this class is dependent on class 1 and class 2, right? If person C and person B wants to debug this code and make changes, then person A is basically stuck. Okay, person A cannot do anything. So what can person A do? Okay, person A might do something like this. Okay, person A might say, oh, I have this class. Okay, person A might have this class. Okay, person A. And right, this class is dependent on class 1 and class 2. Okay, and class 1 and class 2 are very complicated classes, and person A is only responsible for the class code here that so-called takes class 1 and class 2. Okay, so what person A might do, is to say, okay, this class 1 I don't know whether it's bugged, this class 2 I don't know whether it's bugged, it's not really my problem. Okay, but the way to do it, okay, maybe let me do this thing, right? Let's say this thing is it does this, how to say, yeah, it does this very complicated function. Okay, very complicated function, but all it does is to, okay, maybe I'll use something a little less abstract. Okay, let me put it this way. Okay, I'll use a bit more of a concrete example. Okay, so let me use a more concrete example. Let's say this class here will help you calculate cost of chicken burger, right? Chicken burger. Okay, the cost of a chicken burger. So class 1 will help to calculate. Okay, so cost of a chicken burger, what you need to know? You need to know how much a chicken patty may cost. Okay, chicken patty may cost this much. Then you need to figure out the cost of bread, okay, or the buns of the burger, and then other ingredients. Okay, buns plus other. Okay, buns plus other ingredients. Okay, so this class here is responsible for calculating the cost of a chicken patty. This class here is responsible for calculating the cost of buns and other stuff you put in the burger. Okay, so what will these classes do? Okay, maybe behind the scenes, this chicken patty, what does it depend upon? This chicken patty, maybe it depends on the cost of chickens. There's the cost of bringing up chickens. Okay, there are lots of factors, right? The cost of chickens, cost of transporting chicken meat, the cost of transporting chicken meat, and then the what else? The cost of processing. Yeah, processing. Yeah, unfortunately, you have to kill chickens to get chicken meat, and then from the chicken meat, you have to somehow make it into a chicken patty. And then you like, I don't know, put seasoning on it. Then you have your your chicken patty. Okay, so a lot of factors actually go into how much a chicken patty costs. Okay, and maybe it takes, it takes 500 functions to calculate all of this, because you need to pull in real-time market prices or whatever, things like that, right? And then again, for buns, maybe buns are, you have the cost of wheat, the cost of transport, the transport cost, process costs. All right, so imagine to calculate the cost of a bun, okay, you have to pull in all of this data from somewhere. Plus, maybe you have the cost of lettuce, tomato, sauces, everything. Okay, lettuce. Okay, all of these things will cost money, and all this will affect how much your chicken burger costs. Okay, but person A doesn't want to deal with all these functions that calculate how much it costs to raise a chicken, how much it costs to transport chickens, how much it costs to process chickens. And likewise, person A is not responsible for how much wheat costs, the functions that compute how much wheat will cost or estimate how much wheat will cost, how much it costs to transport that wheat, how much it costs to process that wheat, say for lettuce and pickles, mustard, barbecue sauce, whatever, I don't know. Yeah, so and it depends what the customer wants to order as well. You never know, right? So person A is only responsible for say, okay, I put this chicken burger together, the chicken patty and the buns, and maybe you make some profit and pay tax, then it can come up with the cost of a chicken burger. Right? So what can person A do? Okay, person A can do this to make his or her life easier. So person A can, person A can do this. So right, person A can do this. Okay, person A can just deal with the class on top, which calculates the total cost of the chicken burger. Class here is the chicken burger calculator. Chicken burger. Alright, so you cost the chicken burger, and then okay, since class 1 and class 2 are not person A responsibilities, the chicken patty class and the buns and other class, so what person A can do is say, alright, I don't need to deal with the chicken patty class. Let me replace. Okay, replace the chicken patty class. Let me just write here patty. The chicken patty class, let me replace it with the patty will always cost. One chicken patty will cost what? $5, right? Very expensive chicken patty for some reason. Oops, yeah. So where in the original class you had to factor in the cost of chickens, the cost of transport, the cost of processing those chickens into chicken patties. This one will just say, okay, I can make a patty class where the chicken patty will always cost $5. Alright? The chicken patty will cost $5. Alright? And maybe you can make a buns and other class. Buns plus other. Okay, and the buns will cost $1. The buns will cost $1. Okay, this is just a way to fill in some data, because at the end of the day, what this class does is just to add the cost of the chicken patty and the cost of the other buns and other things, and add them together, and then do some text multiplication and whatever to figure out the cost of a chicken burger. Okay, so I don't really need to know what goes on behind the scenes for person A. I just need to know at the end of the day how much a chicken patty costs. So for example, here the chicken patty can just cost $5. The buns can just cost $1, for example, and the other things maybe it costs $2. Alright, so So instead of using this complicated class where there may be other bugs and everything, I can, while debugging for this class, I can just replace the chicken patty and I will make a mock class. I'll call this a mock class. And also this is a mock class. Mockup class that says, okay, the patty will always cost $5, the buns and other things will always cost $1 and $2 respectively. So you know this code will always work because it will just give you back a solid number value. Patty costs $5, buns cost $1, other things cost $2. So so no matter what the other guys are doing with class 1 and class 2, what the other guys are doing with class 1 and class 2, well, I'll let them go and do the other stuff. For me, if I'm person A, I will just sit and try to debug this person class. Okay, person A will just sit and debug this person class. Person A, me, I will make a mock class called this mock patty class. This mock patty class will cost $5. The patty will always cost $5 no matter what happens. And then the mock buns and other class will be like, the buns will cost $1 all the time. The other things will cost $2 all the time. Then, okay, knowing that these mock classes are, very simple code, they will just return me number values that I need. I can then go on to debug class A. And once class A is solved, okay, then I can do away with the mock classes. I can do away the mock classes, and then once person B and person C are done with the chicken patty class and the buns and other classes, okay, I can swap the mock classes out for the real thing. Okay, I can swap the mock classes out for the real thing. Okay, so yeah, so this is the idea of, you want to do unit testing in a team. So that's what you need to do. Okay, so yeah, how do you actually facilitate this in actual code? Okay, it sounds simple. Okay, so person A will just make mock-up patty classes and mock-up other things classes, and then when the actual thing comes, right? The actual class comes. Yeah, when it's time to assemble the program to put everything together, what person A can do is just to delete or not use these mock classes anymore, and then I replace it with the real class 1 and 2 with all the complicated modes of things. Okay, once person A finishes debugging this, yeah, then okay, person A's jobs is done. Then you do class 1 and 2. Alright, so that's ideally what you want to do. You want to so-called be able to swap in and out these dependencies. Right, the whole idea is to be to debug well. Okay, I want to be able to swap out dependencies. Okay, swap out dependencies easily. Okay, that is very important. Swap out dependencies easily so that you can do your unit testing one at a time. Okay, so this is the context for dependency injection. Okay, this is the context for dependency injection. So we at least figure out what this dependency thing is. Okay, for dependency injection. Okay, so this is the context for dependency injection. So we figure out what dependency is. We have not talked about what this injection thing is yet. Okay, so this idea of injection will be a little bit more clear when we actually do code. If we actually code things out, we can actually talk about how injection works. Okay, so Okay, so in the next few videos, maybe we'll pretend to be person A. We'll be making a class that is dependent on some other classes. Okay, and then we want to be able to so-called make this swapping in and out process very easy. Okay, so I think that's it for now. Thanks for watching. I'll see you guys next time. Bye bye.